Hi, my name is Rose, and today I'll be presenting Calibrate Your Listeners, Robust Communication-Based Training for Pragmatic Speakers. Our work takes a Gricean perspective on language, namely that language models should learn to produce contextually useful language. Consider the following reference game, where the goal of the speaker is to disambiguate the target image from distractor images for the listener. A naive language model may generate the literal description, the red shape. This is semantically accurate, but fails to disambiguate the referent from its context. A more pragmatically useful description would be the red circle. One promising avenue for developing pragmatic language models is communication-based training, where a speaker learns to train and communicate with a learned model of a listener. However, this approach commonly suffers from a problem called semantic drift, where the speaker learns to produce utterances that satisfy the listener but diverge from the semantics of natural language. Our work contributions include identifying, diagnosing, and countering one pernicious form of semantic drift. We isolate one form of semantic drift that occurs when scaling communication-based training to larger domains. We first show that the success of prior work for pragmatic language production hinges on a restricted domain of utterances used, such as a domain known as shape world. In the top row, we showed that in this setup, the speaker is able to generalize to new listeners and to new games. However, when we expand the token space, we observe that these speakers are unable to generalize to held-out listeners. This pattern of overfitting indicates that the speaker suffers from a form of semantic drift. Additionally, these speakers rarely use tokens related to shapes and colors, which we also observe in qualitative examples, such as the one shown here in red. Now, having identified this form of semantic drift, we move on to diagnosing it. Intuitively, our hypothesis that we pose in our work is that the observed semantic drift arises from poor uncertainty calibration in the neural listener, which the speaker then overfits to. So, the ideal listener should be uncertain about utterances that are different from their training domain. To test this, we consider three different listeners: single L0, which is similar to the setup done in prior work, then two population-based listeners, which either use dropout or an ensemble of listeners. We see that as hypothesized, the single listener is poorly calibrated. Somewhat surprisingly, so is the dropout-based population listeners. And finally, for ensemble-based populations, we see that they do show better calibration and are closer to the idealized listener. Given this observation, we now test whether we can counter semantic drift using well-calibrated listeners. We show that this is indeed the case. In one of our experiments where we increase the population size, the speaker generalizes to new contexts and to new listeners. This is, however, not the case for poorly calibrated listeners, such as dropout-based populations. Overall, our work highlights the importance of well-calibrated listeners in communication-based training. An ensemble of listeners shows better calibration, and speakers trained to communicate with these listeners avoid semantic drift, generalize to new games and to new listeners. Future work on communication-based training for language models will thus benefit from listener ensembles or other methods for training listeners with poorly calibrated uncertainty.